Hey everyone, I'm Nicole, Senior Dev Advocate at the SDF. I've been thinking a lot about oracles recently since we have this really exciting oracles panel at Meridian, our developer conference later this month. And I remember when I first started in the blockchain space, oracles were one of the first tools that I read about that really clicked in my brain, not just for what an oracle is and how it interacts with the blockchain, but for how the idea of an oracle helps to explain, at least for me, what smart contracts are and why they're so cool. So I'll even start with the example. It is currently very, very hot in New York City, like 35 degrees Celsius, but with 80% humidity, kind of hot. So let's say my friend and I want to make a bet about how high the temperature is going to get at the top of the day. I personally think it'll get up to 36 degrees max, and that's Celsius, sorry. My friend thinks it'll get up to 40 degrees because she is very prone to the dramatic. So we shake on it and agree that whoever wins will get $10 from the other person. But I don't really trust my friend, not when it comes to bets at least, because she's always making bets and then backtracking when she loses. She'll say like she doesn't have cash on her, or she can't Venmo me because her phone is dead, or it wasn't a real bet for whatever reason. And how can we know that, the temperature really got to whatever temperature it was that I had picked, or, in whatever other bet we're making. So maybe I really didn't win that one, right? There's no way to know. So this time we make a bet, and I want to make sure that if I do end up winning this temperature bet, she won't be able to back out and I'll actually get my $10. So we write a smart contract. It's very simple. It states that if the temperature in New York City hits 36 degrees, I win. If it hits 40 degrees, my friend wins. And in all other cases, if it's 35 or below, if it's 37 through 39, or above 41, neither of us wins. So this smart contract that we write is connected to our digital wallets, where we both have at least a minimum of $10 deposited. That's a requirement. When the smart contract then executes, depending on who has won the bet, $10 will be taken from one of our accounts and paid to the winner. So the smart contract makes sure that my friend cannot back out of the bet that she lost. And neither of us have to do anything at all, since the entire transaction occurs automatically thanks to the smart contract, which is really just an autonomous piece of code that self-executes once conditions are met. In this case, of course, the conditions we're talking about are these daily temperatures. But how does the smart contract know when these conditions are met? A smart contract on its own runs on a blockchain network that is intentionally separate from external systems. It can't interact with systems that are beyond its own network. And that's on purpose to make the blockchain more secure and fully decentralized, not vulnerable to those external threats or to single points of failure. But of course, this means that smart contracts running on a blockchain can't interact with the outside world on their own. So the smart contracts that we write won't actually have any way of knowing if or when the conditions of our agreement about the temperatures have been met. So this is where oracles come in. Oracles connect blockchains to those external systems. They're like a bridge between data sources and other off-chain networks and the blockchain, feeding that information into the smart contracts that we write that rely on kind of knowing those real-world conditions. So the smart contract that my friend and I write to manage our bet about the temperature uses an oracle that sources, verifies, and transmits temperature data from off-chain into the contract. Of course, there are different types of oracles used for different use cases. Here, our temperature bet smart contract could use a software oracle that pulls data from the Weather Channel's web API. I'm kind of making that up, but you get the idea. Software oracles, are also used for smart contracts that track payments via an off-chain banking network, for instance. And there are a ton of other software oracle use cases too. But our temperature bet smart contract could also use a hardware oracle. Maybe we actually go out onto the sidewalk in front of our apartments in New York and set up an Internet of Things sensor to track temperature. Data from the sensor would then get fed back into the smart contract via the hardware oracle. We're literally going to the source. There's no question. It's right outside. It hit 36 degrees, as I believe it will. And all of that data gets provided back into the contract so that the contract knows, which one of us if either of us has or will win the bet. And obviously, we. The cool thing about this is that oracles make smart contracts truly autonomous and self-executing, even when they depend on conditions from the real world, because they translate that real world data into something that a smart contract can access. Of course, there's more we might say about oracles and the challenges they pose for smart contract developers. Next time, I'm going to cover the varying levels of decentralization when it comes to oracles, and especially the biggest challenge facing oracles, which is known as the oracle problem. How do you ensure that data being fed onto the blockchain is correct, authentic, unaltered, available, and doesn't rely on any single point of failure? Big questions. So stay tuned for this and more in my next video.